Hi, my name is Edgar Turkan. I'm engineer chemistry, and today I'm going to explain how to implement a stack and queue using list internally, and I'll also cover the time complexity of each operation and implement a stack linked list. A stack works with default principle. That's in or first out. To implement a using single linked list, a simple thread of the head of the list as the top of the stack. For example, push. To push an item and create a new node and insert it at the head of the list. This is very efficient because it only requires updating one pointer. The complexity is the O1. Pop, remove the node at the head and return this value. Again, that is the updated at one pointer, times the complexity O1. To get top, to get a top element, it also look the value stored at the head without modify the list. Complexity is the same, complexity O1, and it's empty. To check if the stack is empty, and simply get whether the head point is null. And again, the complexity is only the O1. This design is efficient because all operations occur one end of the list. And implementing a queue with a linked list, a queue follows the FIFO. It's the first in, the first out. To see in previous class. To implement an efficient with a linked list, I'm gonna take 2 pointers, head and tail. That the head means the front of the queue and the tail is rear of the queue. In queue, to include create a new mode and attach all the tail of the list. Then update the tail pointer. The complexity is O1 and the queue. To the queue, remove the node at the head and return its values. But in also scenarios, size is maintained the counter decrements which every unit decrements and each DQ I can return the size immediately. The complexity is the same, O1. For last is empty to check if the queue is empty and check where the hell is null. So in summary, a linked list is an awesome structure for implementing both the stack and queue efficiently by using the head, the queue for the head and the tail of the queue. We ensure that all the keys operation run in constant time. And thanks for watching the video and see you next time.